Hello everyone, myself Orgodik Mandal again, and this is not a screencast video. This will be a solution type video in which I will go over my solutions over the problems which I was able to solve during the contest, that is problems A, B, C and D. And by seeing the number of submissions of problem E and also by reading problem E, I didn't find any hope of solving it in the required in the remaining time now. So I thought that I can do some sort of a editorial type video. So let's start. Now starting with problem A. Now in problem A, what you will be given is that you will be given an integer n, and the value of the integer will be between 10 and 999, and what you have to do is that you will have to perform the minimum number of change of digits to make this number a multiple of 7, that is that particular number should be divisible by 7. Like for example, in the sample test cases for 42, since this is already divisible by 7, so we can okay, and you don't have to print the minimum number of operations required. You have to print such a number which is divisible by 7 and which can be obtained by applying those minimum number of operations, and if there are multiple answers possible, you can print any of them. Like in this example 42, since it is already divisible by 7, so we don't need to change any of the digits, and so our answer is 42 only. And so our number of operations required is 0 and our answer is 42. Now if for the case of 23, since this is not divisible by 7, we can make 23 divisible by 7 in one operation, in just one operation, by either making it 21 or we can make it 28. Yes, I think these two are the cases. So we can print either of 21 or 28. In my implementation, I think I printed 21 only. And for the third test case 377, here also we can make this number divisible by 7 by changing only the first digit, that is the digit 3, by making it to 777. So by using only one operation, so the output is 777. There may be other possible outputs for a single n also. So how to solve it? How I solved it is that I just brute forced. Okay, so let's go to the Jamboard once. I just brute forced over the all the possible, and as you can see, the number of different possible values of the divisors of n is pretty less. That is, it will be up till 1000 divided by 7 into 7, which is I think approx what will be approximately which will it will be approximately 1000 divided by 7, which is approximately, and this floor into 7, which is approximately I think 999 something. So we can just iterate over all the multiples of 7 from 7 up till this number, which is at most 999, not greater than 999, and for each one of them we will try to find the minimum number of operations required. Okay, and now for example, let's say that our current number is 23, and we are checking for a particular multiple of 7, which is, let's say, 343. So in this case we cannot make it, since our number cannot contain leading zeros. Just a second. Since our number cannot contain leading zeros, so we can just we cannot increase the number of digits of my current number, so we can just replace a single digit, so something else. So here, from here, what we can conclude is that the number of digits in the number n, and also in the multiple should be same. Like from 23 we cannot also make 7 since the number of digits in them are not same, but from 23 we can make 21 or 28, and also 35, like all the multiples of 7 having only 2 digits. So as I think we can just go over my code, and that would be pretty much it. So I have just initialized my here my answer is storing the minimum number of operations required, and my current is storing the a particular number which can be obtained by applying these many operations to n. Now in the solve function I am calculating the minimum number of and now I am iterating over all the multiples of 7 from 7 and up till less than equals to 1000, I plus equals to 7 in this loop, and now I am just calculating the minimum number of operations required to change n into I, and if the minimum number of operations is less than my current answer, then we will update our answer and also our current value, and finally we will just print our current value. Now how to get this solve function? What I have done is that I have just convert this both the integers to strings s1 and s2, and now if their lengths are not same, then we will just return infinity since we cannot, and here infinity is 1 in 9 plus 5, and which is pretty much huge. Our number of operations will be at max 2 or 3 only, so we can just return infinity from here. That is, it is impossible to make s1 equals to s2, otherwise we will just compare the individual digits of s1 and s2, and if s1 of I is not equals to s2 of I, we will just increment our answer, and then we will return answer from this loop. So that's it for problem A. I think this was a pretty easy problem, and though I still took us approx 7 minutes to solve this problem. Now coming towards the problem B. Yes, problem B was another easy simple observation based problem, but here also I took a lot amount of time to solve this problem. So just let's say how many people solved E. A lot of people solved D. Not a lot of people, but quite a lot of people. Okay, so now coming towards problem B, minority. So here in this problem so here in this problem what we are given is that we will be given a string consisting of zeros and ones only, and you have to find such a substring of this original string which contains a particular character exactly more than strictly greater than the other character. Like for example, in this huge test case we can choose this substring of this original string, and now in this substring as you can see it contains 5 characters 0 and 6 characters 1. So 0 is a strict minority. Strict minority means that in this particular substring this character is present strictly less number of times than the other character, which is 1 in this case. So we can remove all the occurrences of 0 from this substring, and we have to perform this operation exactly once, and we have to just output the maximum amount of characters that can be removed. So if you think about it, this is a pretty easy problem. So initially let's say that we will have a string consisting of zeros ones something like that. Cool. Now if the number of characters of a certain character is greater than the other character, like in this example the number of occurrences of 0 is 1 2 3 4 5 6, and number of occurrences of 1 is only 4. So we can take this whole string as a substring, and we can just remove all the occurrences of 4. We cannot remove greater than 4 greater than 4 occurrences of any character, because to remove greater than 4 occurrences of any character we have to choose the other character which has since we have to choose the other character as our candidate of minority, and our current character should at least contain greater than equals to 6, which is not possible since here it is this is the majority and this is the minority. Since here the count of the majority element is 6 and the count of the minority element is 4, so we can at most so if we choose this whole substring we can remove the four ones from this, but we cannot remove more than 4 ones since there are only 4 ones, and if we want to remove more than 4 zeros, that is let's say 5, then we have to have at least 6 ones to make it a majority element, which is not possible. So if the counts of zeros and ones are not same, then we will just print the minimum of the two counts. And now otherwise what we can do is that is if the counts are same, then we cannot take the whole string as our answer, but we can just take either this substring or this substring. Okay, and now why this is actually true is that, and because the since the number of ones is equal to the number of zeros. Cool. Now if we choose this substring, if we choose this whole substring that is from index 0 to index n minus 2, then if this character is 0, and now firstly since ones equal to zeros, we cannot remove our answer has to be less than ones, since to our answer to be ones there must be at least zeros plus there must be at least ones plus 1 zeros which is not present. So our answer is always less than ones, and we can make our answer always ones minus 1. How? If we choose this substring, so if this character is 0, then the count of elements in this substring would be ones minus 1 comma and zeros. So here zeros is strictly so here ones minus, so here ones minus 1 is strictly the minority count, so we can just print it. And also otherwise if this character was 1, okay sorry, if this character was 0, then this should be ones and zeros minus 1, so we can just print zeros minus, so we can just take that substring and use zeros minus 1 as our answer. So our answer will be zeros minus 1 in that case. So let's go to my code here. It's a very simple problem. I took a lot of time in solving this, and I am angry with me about that. So we will just count the number of ones and zeros in this substring, and if the count is same, we will output ones minus 1. Otherwise we will output the minimum of ones and zeros. That's it. So now coming towards problem C, let's see what's my rank right now. Okay, so this is my rank right now. So now let's coming towards problem C here. Okay, problem C was another easy problem, but I liked problem D, but I don't know how this much people solve problem D. Okay, so I think problem C will be pretty much easy, and it is very much difficult to explain. So I think I should just move to problem D. because it's an easy problem, but it consists of a lot of statements which will be difficult to explain, and you can easily solve problem C, and that is, it is not much of an interesting problem. But here comes the interesting problem, the problem D. And here in problem D, what you will have is that you will be given an array of integer. Initially what you will have is that you will have an array consisting of only ones. Okay, so every element of that array will be only ones. Okay, now what you can do is that you can perform this operation by choosing any element of the array. That is, you choose the ith element and make a of and add a of I, and you can also choose any integer x, and you can also choose any integer x which is greater than 0, and you can just add ai by x flowed down to a of I. That is this thing, and you can perform this operation any number of times. Okay, and after performing all these operations you will receive ci points if and only if ai equals to bi. That is, if you can make a of I, that which was initially 1, and after performing some number of operations you can make it to b of I, then you will receive c of I points for that. Cool. And if you cannot make it, so you can't do that. Okay, and you have to determine the maximum number of points you can receive by performing no more than k operations. Okay, so you can perform only k operations. Now as you can notice from here, the value of n is at max 10,000, I think. What is it? 1000. The value of n is at max 1000, and the value of k is also is at max 1 is 6. But here comes the trick. The value of k is at max n log n, or n into 12 to be more precise. Now how it comes? Okay, so I have a proof of that, but it's I have a proof of that, but it's not that much clear actually. So let's say you start with the element 1. Now from 1 you can make it 2. How? By 1 plus 1 by 1. Cool. Now from 2 you can make it to 4. Okay, now by making it 2 plus 2 by 1. Now from 4 you can make it to 8 by making it 4 plus 4 by 1. Okay, so as you can see here, you can always increase the element by multiple of 2 at each step. So from here I got the intuition that the number of operations okay, and also the value of b of I is at max 1e3. Okay, so I got the intuition that the maximum maximum number of operations required for each element will be at most log of 1e3, that is 10. And I also proved this thing by running a Dijkstra type algorithm starting from the node 1, and from the node 1 I will be initially I will push that node into my set, and from that node 1 I can go to the node 2. Now from 2 I can go either 3 or 4, like this. I will run a Dijkstra, and using that Dijkstra thing I calculated the minimum number of operations required for each element, and to my surprise that number came out to be 12 only. That is the maximum number of operations required to make any element to b of I starting from 1 will be at max 12. Okay, and here is my code for that thing. Okay, here I have just maintained a stored array which stores the minimum number of operations required to reach that element starting from 1, and initially I have inserted into my set a key pair value, a pair of elements. The first element is the minimum number of operations required, which is 1, which is 0 for 1, and also in store of 1 I have updated my answer. That is, for 1 the minimum number of operations required will be 0. Now here it's a simple Dijkstra thing, and here the from the node I the edges will be node plus node by I, where I can be start from 1 to node. So and if now is and if that now element, that is the child node, gets out of bounds, then we are not interested in that, so we will just continue from that. And here is my and here is the simple Dijkstra thing. You can if you don't know about the Dijkstra algorithm of graphs, you can just google about it. Okay, now okay, so now what we have got is that although k is actually 1 is 6, but we will require at max n into 12 operations. Cool. So we can make k, so our k value is not up till 1 is 6, it's up till 12 into 1 e3 at max, because the rest of the operations are not required. We can make all the elements to be equal to their corresponding b of i's by this much number of operations, upper bound. Okay, so now we can do something like a knapsack dp here, where dp of ij. Okay, let's move to the okay. So now we have some elements, and for we have n elements, and for each elements we have a cost array, which denotes the minimum number of operations required to change this element to b of I. Cost something like 4 6 3 2 like this. And also we have a price array, which is the cost which we will get if we perform this many number of operations on this array. So it will also be something like this. So we can do a dp of ij here, where dp of ij denotes the cost, the maximum cost we can get. No, here dp of ij denotes that up till index I, what is the maximum cost we can get by using j operations, and from it there will be two transitions, just like knapsack dp. If we include the current element, so it will be max of dp of, so this should be max of dp of I minus 1j if we don't include the current element, or if we include the current element, then it should be dp of I minus the cost required for that I minus 1, and the cost required for that element, that is j minus cost, plus c of I, j minus, this is minus actually, j minus cost, and plus c of I should be added also, plus c of I. So we can just do this dp, and finally we will print and finally we will just check for each k which value of j for the dp of n minus 1j, for which j gives us the maximum cost, and we will just print them. Okay, we'll just print them. And in my code I have actually done it using 1D dp. You can I think you can also do it using a two-dimensional dp also, but I have done it using 1D dp because it takes less memory, and also since the ith position depends only on the ith minus 1 position, so we can reduce our two-dimensional dp to one-dimensional dp here, and finally we will print our answer. by here dp of I denotes the maximum cost we can get by using I operations, and we are updating our dp values in each step. Okay, so that's it. I am not going over problem C here because it is easy problem, and it also is very much lengthy to explain, but it's very much easy to solve it. So I am not going over problem C here. So that's it for this video. Thanks for watching this video, and let's see what is my final rank up till now. Okay, standings. Okay, so here is my final standings. Okay, cool. 1 4 4 2. I have got a good performance after a long bad after a long strike of bad performances, so it is really great. So thanks for watching this video. Okay, bye.